So good day. This is Michael from ID 121, and this video is the second in a series discussing the coverage for CALENG2, CALENG2 Long Quiz 1. So if you haven't watched the other video, there's another video right before this one. So these questions are taken from Syntax's Long Quiz 1 reviewer for CALENG2. So without further ado, allow me to turn off my camera and let's begin. So the question is number 6, evaluate the integral dy over e raised to y sine squared e raised to negative y. So we can go ahead and let our u equals negative y with our du equals negative e raised to the negative y dy. So we can simplify our expression. Let's substitute u here. We have e raised to the y here at the denominator. So we can also rewrite this as negative dy over e raised to the y. Since there's a negative here at the exponent, you just put that at the denominator. So rewriting, this will become, let's add a negative sign here, negative. And since we have 1 over sine squared here, we can just rewrite that as cosecant squared e raised to the negative y. And then we have our, since we added negative here, we will write negative also inside, negative dy over e raised to the y. And then let's start substituting our u here. That would be negative cosecant squared u du, which is just one of our basic formulas, which is negative cotangent u plus c. And let's substitute our u back into the equation. That would be cotangent e raised to the negative y plus c. So we have our final answer. Next, we have evaluate sine 2x cosine 2x over 1 plus 3 cosine 4x dx. So let's see what will happen if we set our u here into the denominator. Let's set our u as 1 plus 3 cosine 4x and let our du be 12. The derivative of cosine x is negative sine x. So that would be negative 12 sine 4x. But don't forget our dx. Since we have here, notice we have here at our numerator sine 2x cosine 2x. One of our trig identities would be sine 2u equals 2 sine u cosine u. So we can rewrite our du as just equal to negative 24 sine 2x cosine 2x dx, since we have sine 2x and cosine 2x here at the top. So let's manipulate this equation, this expression a little bit. That would be, since we have our du as negative 24, let's just add 1 over negative 24 here at the left side. So we can get negative 24, copy this, sine 2x cosine 2x dx, and then just copy our denominator, 1 plus 3 cosine 4x, and then let's substitute our u, negative 1 over 24. That will simply be, this whole one would just be du over u. So that is one of our basic basic integration formulas, which is equal to -1 over 24 ln u absolute value plus c, which is equal to -1 over 24 ln absolute value of u 1 plus 3 cosine for x plus c. So let's just go ahead and put a box here. That's our final answer. For item 8, this will be a definite integral. And so our first step would be to just go ahead and from pi to 0, we can go ahead and simplify this. That would be sine squared x minus 4 sine x minus 4 plus 4 dx. One of our trig identities would be dealing with cosine squared x or sine squared x. In that order, this would be equal to 1 plus minus cosine 2x over 2. So for cosine squared x, that would be a plus, and then for sine squared x, that would be a minus. So let's rewrite this sine squared x into this. That would be from pi to 0. That would be 1 minus cosine 2x over 2. Let's just copy the rest here. Minus 4 sine x plus 4 dx, which is equal to pi 0. We can actually start evaluating this at this point already. So this will just be evaluating the integral. That would be 1/2 x, 1/2 x minus 1/2. The integral of negative cosine 2x would just be negative sine 2x. So, but since we have, there's a 2x inside, there's a constant, so we will multiply it by 1/2. And then that will become sine 2x. And then that will be plus 4 cosine x plus 4x. And then this is evaluated from pi to 0. And then let's simplify this a bit further. That would just be 9 over 2x minus 1/4 sine 2x plus 4 cosine x from pi to 0. So substituting 0 inside our expression here, that would just be 0. Sine of 0 would just be 0. And cosine of 0 would just be 1. So that would be just 4 minus, and then plug in pi here. That would be 9 over 2 pi. Sine of 2 pi would just be 0. And then cosine of pi would just be -1. So that would be -4. So simplifying this further, 4 minus -4, that would be 8 minus 9 over 2 pi. Then let's have a box there for our final answer. Number 9 would be a word problem, which states that the function of a curve has its concavity given by the equation y prime prime equals 2x plus 3 with a horizontal tangent line at point 0,9. Find the constant of integration of the original function y equals f of x. So we know that if we get the integral integral of y prime prime, that would produce y prime, and then the integral of y prime, that would produce just y. So knowing that, let's apply that. We have y prime prime equals 2x plus 3. Let's get the integral of this. Y prime is equal to 2x squared over 2 plus 3x plus c1. So this cancels out. And then let's integrate this once again to get y equals x squared. Oh no, that would be x. That would become x cubed over 3 plus 3x squared over 2 plus c1x plus c2. So we have these two new equations right here. That's 1, and that's 2. It says here that the equation, it has a horizontal tangent line at point 0.9. Horizontal tangent line at point 0.9, which means to say that at x equals 0, the slope at x equals 0, the slope which is given by y prime, this is the slope function. So since it's a horizontal tangent line, that must mean, since it's horizontal, slope must be equal to 0. Hence, y prime is equal to 0. So from our equation 1, we will set y prime 0 equals x is 0, 0 squared plus 3 times 0 plus c1. So our c1 must be equal to 0. So we will go ahead and write that here. Our c1 is just 0. There's also a point there on the original function, y equals f of x. 0, 9 exists at y equals f of x. So that just means to say that at x equals 0, y is equal to 9. So we will use this one, the original function. We will use that from 2, y equals to 9 equals x cubed over 3, 0 cubed over 3 plus 3 times 0 squared over 2 plus c2. So our c2 must be equal to 9. So that will be our constant of integration. Therefore, our y must be equal to x cubed over 3, x cubed over 3 plus 3x squared over 2 plus 9. So there. For our last question, this would be making use of our summation formulas in sigma notation. So you can refer to the ones here that are written in red. So the summation from I to n is k. The summation of I from I to n, that would be n times n plus 1 over 2. And there's also I squared and I cubed over here. So we will consider this 50 to be our n. N equals 50. So let's start rewriting this. This would just be 3 times I squared. We will just look at this one. 3 times n, 50 times 50 plus 1, 51, 100 plus 1, 100, 1 over 6 plus 2i. So that would be plus 2, our n times n plus 1, so that would be 50 times 51 over 2 plus just a constant. So this, we'll be using this. This would be just a constant. So refer to that. That would be 3, just 3 times 50. It's 3 times 50. So let's zoom out just a little bit. So this would be just equal to 128,775 plus 2,515 plus 150. And then our final answer would be 131,475. In Syntax's CALENG2 Long Quiz 1 reviewer, there are some additional problem-solving exercises with solution included in the file. So if you need any further practice, you can refer to that. So this will be our last item for our CALENG2 Long Quiz 1 reviewer. Thank you so much for watching. Allow me to just turn on my camera here. Thank you so much for watching. So if you want to book an appointment or if you want to book a tutorial session with Syntax, you can just scan the QR code that will be placed here on your screen. And thank you so much. This has been Michael from Syntax. So this is Syntax, paving your way to excellence. Thank you so much for watching our video. Thank you.